I'm showing you a video which is very relevant. This is a video I took several years ago as a spine surgeon. And there are essentially multiple problems with the way spine surgery is performed today, in my opinion, as an ex-spine surgeon. The video, first of all, does not show you anything about relevant anatomy. It's very difficult to understand what is going on. But most importantly, it actually destroys healthy tissue in order to access the pathology. So the bad news for you for sticking around so long today is all of us are going to develop spinal stenosis. It's just a sign of aging. Of course, not all of us will end up in the operating room, but there are over 300,000 laminectomy cases performed in the US every year. Both open and minimally invasive techniques are used. And yeah, that's a real picture from the operating room that's being performed essentially every day. So open techniques, as you can imagine, are very destructive. And all current techniques result in a violation of healthy muscle, tissue, ligament, bone, tendon, essentially resulting in prolonged hospital stays, pain and morbidity, etc. So there's currently really no technology available to treat lumbar spinal stenosis from inside of the spinal canal. So how to approach the inside of the spinal canal without violating healthy tissue, right? So that's the question. Well, you can do it via the sacral hiatus, and that's what you see here in this picture of a cadaveric sample. And I say sacral hiati are like opinions. I think hiati is the plural of sacral hiatus. Sacral hiati are like opinions where everybody has one. So the good news is there are essentially three morphological types, and all of these are amenable to access from a surgical perspective. So the approach is not really novel. It's used daily in anesthesiology and pain management. It's a very common procedure, both inpatient and outpatient. This technique has evolved over the years into what's called epiduroscopy, and that's what you see on the top left image. You see a very lousy picture of the dura. You see the disc, and you see some kind of a blue probe there. Bottom x-rays demonstrate that doctors actually do place endoscopes via the sacral hiatus and have been doing it actually since the 1990s. This is a very well-described approach. You can see here an access trocar, an endoscope that's being placed inside the spinal canal from this approach. The point I'm trying to make is we're not inventing a new approach. Although it's commonly performed, it has multiple limitations, and the list is long. First and foremost, it's very technically challenging, which is why adoption rates for this type of technology are very low. You have limited control of the endoscope. It's highly dependent on surgeon dexterity. It's very difficult for the surgeon to understand where they are in relationship to the anatomy. Where am I? That's not a question a surgeon wants to be asking during a spinal procedure. Very limited control of the instruments and limited instrument sets. Challenging workflows, limited field of view. There's really no way to retract or protect the neural structures. Radiation exposure, the surgeon is hunched over at the patient at the bedside, and of course cost. So our solution is the semi-autonomous platform for spinal decompression, which we feel should be deployed via the sacral hiatus approach. So you see the robot, it's a very small device, and this is, of course, a schematic targeting 3 by 6 millimeter device that has two portals, a primary portal and a secondary instrument portal. You can pack a lot, actually, into a small amount of real estate. As you can see, suction, laser irrigation, light camera, flexible instrument portal, and an EM tracking system. So this is a schematic of how the robot looks deployed through the sacral hiatus. And here's how you can envision it accessing the ligamentum flavum, which is located just below the spinous process. So we feel there are multiple advantages to this way of accessing spinal pathology. First and foremost, the surgeon gets to sit. So I don't know how familiar with spine surgery, but the surgeon never sits, right? So it's a standing only procedure, which can take hours at a time. You're away from the operative field, meaning you don't suffer from radiation exposure. The sacral hiatus approach is simple in a sense that it's once again used daily in the operating room, so we're not introducing any novel instruments or complexity there. The EM navigation allows the surgeon to have anatomical awareness. And one of the limitations today in spinal endoscopy is anatomy recognition. So you have a camera, it's showing you an image, but what is that I'm looking at, right? So that's a very big limiting factor from adoption from a learning curve perspective. So we have built a team of medical professionals that actually mark all the endoscopy images for us as far as relevant anatomy, so fat, nerve, disc, ligamentum, etc., bone. And then we feed that into the computer and we train our algorithms to recognize live endoscopy camera image video streams, which we feel have multiple advantages. So first of all, we offer multi-class tissue segmentation based on the camera feed. This is, of course, enabling type of a technology which we feel will flatten the learning curve, so reduce the stress factor for the doctor in understanding what the anatomy is. From a robotics perspective, main advantages of actually having a robot is that there's really less dexterity dependence, so the surgeon dexterity does not play as much of a role. The software can stabilize the movements of the robot. There are built-in safety features, such as preventing the robot, because we track where it is from the EM sensors, preventing the robot from rapidly moving towards a nervous structure, neural structure. The robot can be rigid when needed and allows for debris removal, because always the question is, how do I remove what I need to remove and what's the channel and way of doing that? So this is quickly about our team. We have a very experienced team. Both myself and Christian have founded Holo Surgical before in 2015. Company was acquired in 2020. We have reconstructed the team. Right now we have 10 people. We have filed our foundational patents. We have a second generation prototype of the robot, and we have our first generation AL algorithms that are currently working. So financial status and planned milestone. This is a founder financed company. We anticipate our first cadaver lab in Q3 of this year. We plan to be CE mark ready by fourth quarter of 2024. And we are raising money right now to meet these milestones. Thank you.